The use of 3 turbofan engines is unlikely just for ferrying a large platform, rather, the power output likely plays many key roles. This probably includes energy generation for a vast electronic loadout ranging from long-range radar or other sensor arrays as well as directed energy weapons. While it was known that China had been developing a so-called 6th-generation combat aircraft system, the reveal of both the J-36 and J-50 was surprising. First, few would have expected China to show such platforms before the United States, which had initially championed the concepts involved in 6th-gen combat aircraft via its next-generation air dominance program. Second, China revealed 2 different fighter programs with parallel research, development, and production tracks. Putting it bluntly, China revealed both the world's first and second 6th-generation fighter aircraft within a matter of hours of each other. The year of 2025 has arguably opened with China becoming the focal point of global defense aviation. One of the unique and unexpected aspects of the J-36 is that it relies on 3 turbofan engines. Currently, these engines might be the WS-10C, but this may be a transitional or temporary solution until a more advanced power plant is available. Chengdu may be waiting for the WS-15 to become available, which reportedly provides both supercruising and a greater thrust for an improved thrust-to-weight ratio. However, it is worth noting that the choice for 3 engines may not be due to the size of the aircraft alone, but to achieve a specific capability set in the future. Basically, 3 engines would allow the J-36 to generate significant electrical power, a key need for supporting its advanced avionics, different sensors, high-output EW systems and potentially, DEWs such as HELs and/or HPMs. In other words, the choice for 3 engines has less to do with sustaining the J-36's size or weight as one might assume with a traditional design approach, but to enable its role in China's next-generation air warfare vision. In this context, the J-36 would serve as both a focal node managing a formation of UCAVs, smart munitions, and other assets as well as a long-range, high-performance standalone combat aircraft. In fact, even if one were to restrict the J-36 to solely being a focal node for managing or leading MUMT formations, the effective use of that could rely on electronics. Basically, to manage drones at scale, one would need onboard extensive computational power, and to run that alongside high-powered data links for two-way communication will require lots of energy. This electronics stack would not only involve the processing as well as sensor or radio arrays, but also the required cooling systems. The way a fighter generates electricity is through its engine. In theory, perhaps, 1 or 2 engines could be sufficient if the platform's roles were restricted to specific missions, such as MUMT alone or only deploying DEWs. However, it seems that China is working to make each J-36 an individually versatile system, one that can play multiple key and, to be clear, power-intensive roles to support UCAVs and smaller crewed assets. To support this mission, it is possible that the J-36 or some future variant could adopt a variable cycle engine VCE. VCEs enable individual turbines to spin at different or varied speeds rather than one fixed speed for all. It can lead to better fuel efficiency and may tie into supporting other power needs better, such as those of electronic subsystems. The potential MTOW of the J-36 could be from 50 tons to 60 tons, making it significantly larger than traditional strike fighters. This large size likely translates into significant fuel volume and large internal weapon bays, enabling for long-range and heavy payloads. Currently, one can only speculate as to the range and payload specifications. However, one can infer that China's principal goal in terms of reach is to be able to cover the first island chain, thus, a combat radius for covering the first island chain ideally without mid-air refueling could be expected. In turn, the use of long-range standoff weapons can help extend the J-36's strike and impact reach to potentially the second island chain. From a payload standpoint, one can expect the J-36's internal weapons bay to support a wide assortment of munitions, from new air-to-air missiles like the ultra-long-range PL-17 with a speculated range of over 300 kilometers to precision-guided glide bombs and air-launched cruise missiles. However, munitions may not be the sole purpose of the weapons bay, even if it can carry a large payload. Rather, the internal weapons bay could be used to house DEWs and other non-kinetic equipment. Moreover, instead of carrying its own munitions, the J-36 may use its electrical output to leverage new high-powered data links and, in turn, coordinate UCAVs to deploy their munitions. Once again, the point of the J-36 is not to treat it as a traditional fighter, but a focal node in a wider air combat system. This system will include UCAVs of varying sizes, possibly including relatively large drones that may match up to small crude fighters in size. For its own weapons complement, the J-36 may issue traditional munitions and lean on DEWs instead. Its three-engine configuration speaks to a focus on power output, one of the key constraints alongside the size of the housing platform of many DEW types. Potential performance capabilities, of course, the J-36 seems to leverage its own unique performance advantages. For one thing, its three-engine configuration and slimmer airframe may result in both a stealthier and more aerodynamic design. In terms of the latter, the J-36 could potentially be able to fly at high speed at least Mach 2, giving it a stealth and speed advantage. This can be used to ensure the J-36 is difficult to track and engage, which, in turn, makes it harder to neutralize AMUMT formation led or managed by this fighter. In addition, the J-36 could also leverage its own EW suite to jam radars, including those on seekers and potentially, communications between enemy air assets. One could potentially see a scenario where the J-36 operates at high altitudes and flies at high speeds. In parallel, the Shenyang J-50 could be the slower, maneuverable, and lower-flying threat for more traditional fighter-type operations, like long- and or short-range air-to-air engagements and combat air patrols. For example, to reiterate, there is no consensus on the specifics of what constitutes a sixth-generation fighter 6GFA. However, the Chengdu J-36 and Shenyang J-50 both carry specific airframe design elements that make them distinct and much improved over all other current-generation aircraft, including America's cutting-edge platforms, like the F-35.